Hi, today we're gonna take a look at how to convert improper fractions to mixed numbers. Are you ready? First, we need to remember that in a fraction, the top number is the numerator and the bottom number is the denominator. Once again, the top number is the numerator and the bottom number is the denominator. We also need to remember the improper fractions. An improper fraction is a fraction where the numerator, the top number, is greater than or equal to the denominator, the bottom number. For example, 7/2 is an improper fraction, given that the numerator 7 is greater than the denominator 2. Nice! Let's start with this example. We're going to convert the improper fraction 7/2 to a mixed number. So first, we're going to see this fraction as a division. We're going to divide the numerator 7 by the denominator 2. You can use the 2 times table. And now, how many times does 2 go into 7? Once again, how many times does 2 go into 7? Well, 2 goes into 7 3 times. We're going to put that 3 over here. Next, 3 times 2 is 6. To get 7, we need to add 1. 3 times 2 is 6. To get 7, we need to add 1. Finally, we keep the denominator the same, so 2 come over here, and we're done. The answer is 3 and 1/2. Don't forget that a mixed number is a number containing a whole number and a fraction. It's important to remember the steps, however what really matters is to understand what we are doing here. In this problem, the original denominator is 2, so we are working with halves. Yes, we are working with halves. For example, how many halves are in 3 wholes? How many halves are in 3 wholes? To find the answer, we're going to convert 3 wholes to a fraction with denominator 2. So we're going to multiply 3 times 2 over 2. 3 times 2 is 6, then the denominator is 2. 3 wholes is equivalent to 6 halves. We have 6 halves so far. To complete 7 halves, we need to add 1/2. That is right. And we have 1/2 over here. That's why we have 1/2 over here. In that way, we can prove that the improper fraction 7/2 is equivalent to the mixed number 3 and 1/2. Let's continue with another example to show you something different. In this problem, we're going to convert the improper fraction 9/4 to a mixed number. So first, we're going to see this fraction as a division. We're going to divide the numerator 9 by the denominator 4. You can use the 4 times table. And now, how many times does 4 go into 9? How many times does 4 go into 9? Well, 4 goes into 9 2 times. We're going to put that 2 over here. Then we're going to multiply. 2 times 4 is 8. To get 9, we need to add 1. One more time. 2 times 4 is 8. To get 9, we need to add 1. Finally, we keep the denominator the same. So 4 come over here. That's it, we're done. The improper fraction 9/4 is equivalent to the mixed number 2 and 1/4. If you don't like this division method, don't worry, we can try with another one. Once again, we're going to convert the improper fraction 9/4 to a mixed number. This time, to divide 9 by 4, we're going to use the division by grouping. The dividend is 9. Here we have 9 objects, 9 shields. Also, the divisor is 4. So, how many groups of 4 can we make out from 9 objects? How many groups of 4 can we make out from 9 objects? Well, here we have one group, and here we have another group. In total, we have 2 groups. 2 is the quotient of this division, and it goes up here. As you can see, there is one object, there is one shield left over. 1 is the remainder, and it goes over here. Finally, we keep the denominator, so 4 come over here. That's it. We're done. The improper fraction 9/4 is equivalent to the mixed number 2 and 1/4. Let's continue with another example. This is the last problem. We're going to rewrite the improper fraction 5/3 as a mixed number. So first, we're going to see this fraction as a division. We're going to divide the numerator 5 by the denominator 3. Here we go. How many times does 3 go into 5? How many times does 3 go into 5? Well, 3 goes into 5 one time. We're going to write that 1 over here. Then we have 1 times 3 is 3. To get 5, we need to add 2. Once again, 1 times 3 is 3. To get 5, we need to add 2. Finally, we keep the denominator the same, so 3 come over here, and we're done. The improper fraction 5/3 is equivalent to the mixed number 1 and 2/3. To check our answer, we're going to model the improper fraction 5/3. So first, we need a geometric figure. This time we're going to use rectangles. Yes, this rectangle represents one whole. Next, since the denominator is 3, we're going to divide this rectangle into 3 equal parts. Yep, into 3 equal parts. Now we're going to take one part, only one part. As you can see, we have divided this rectangle into 3 equal parts, and we took one of those parts. Therefore, this part represents 1/3 of the rectangle or 1/3 of a whole. The next part also represents 1/3 of the rectangle or 1/3 of a whole. And here we also have 1/3. We need to model 5/3, so we're gonna take 1/3, 2/3, 3/3, and hold on, there is a problem over here. We need more thirds, so we're going to draw an identical rectangle, also divided into 3 equal parts. We already know that each part represents 1/3 of a whole, so here we have 1/3, 1/3, and 1/3. Let's try again. We need to model the improper fraction 5/3, so we're gonna take 1/3, 2/3, 3/3, 4/3, and 5/3. We're done! Here we have the model that represents the improper fraction 5/3. Let's take a second and let's go back to the first rectangle. As you can see, we have taken this rectangle completely. Yes, we took one whole rectangle or one whole. And here in the second rectangle, what part of the rectangle did we take? Well, we took 1/3 and 2/3. That is right. We took one whole and 2/3, or just 1 and 2/3. Once again, the improper fraction 5/3 is equivalent to the mixed number 1 and 2/3. That's all for today. Up here you will find more lessons about mixed numbers and other videos. See you next lesson and have a good day. Bye!